965. That is your beta, which is this one. So you need this beta for you to solve, for you to be able to solve D sub 2. Okay? So to solve now for D sub 2, is to go back to cosine law. So D sub 2 now will be D sub 2 squared equals D sub 1 squared plus D sub 2 squared, plus 120, no? 120 squared minus 2 D sub 1 times 120 cosine opposite to D sub 2. Take note, opposite to that D sub 2 is beta. Okay, this angle. So looking the entire figure, you have D sub 2 here, and opposite to that side is angle beta. So that is the angle to be used here at cosine law. Okay, so cosine beta. Take note that beta is already known. Okay, next. So ending up with your D sub 2 equivalent to 467. 0.8263826. That is newtons. Okay, so that is your D sub 2. After finding D sub 2, the next thing that you need, okay, is this angle. I need this angle for me to be able to find R, because we need this angle to find R. Opposite to that angle is actually your R, so we need this angle. So how shall we do that? First, we need to find this angle here. Okay, this one. So we will call this angle gamma. So if we can find gamma, all we need to get lambda, okay, is just subtract this gamma from 90 to come up with your lambda, which is the angle to be used to find R. Okay, so we will continue now. So to find this is by sine law. So by sine law, okay, by sine law now, we need sine gamma as to, take note, pwede lang balik-balik na rin, no? Basta consistent lang kayo, no? It has to be consistent. If you have distance, I'm sorry, take note of this. It should be, oh my goodness, the formula should be the first here. We have D sub 1 as to 120 sine. Dapat, no? Baliktad. So I'm going to correct this. Yung kanina. So that is D sub 1 as to sine 120 degrees. Okay, we have to correct that a while ago. Sorry for the mistake. D sub 1 as to 120 degrees, which, and then sine 200 as to sine phi, such that your phi will be equivalent to 26. So this is wrong. So taking now the sine phi as to sine phi, this one, sine lambda rather, sine lambda as to that side opposite of that lambda. Okay, the entire figure we will try to see so that you will understand. Sine lambda we will have now sine lambda, this is gamma, the sine of gamma as to the side opposite, which is d sub 1. So sine gamma as to d sub 1. Okay, you see the figure, gamma pala, opposite is d sub 1. Next is sine beta d sub 2. So I can solve for gamma because this is known, this is also known, this is also known. So you can solve for gamma, ending up gamma equivalent to how much? 123. After that we have 44 degrees. 44.00348822 degrees. So that is the amount here. So to solve now for lambda, all you have to do is to get lambda is just equivalent to 90 minus gamma, which is equivalent now to 45.9965 1178 degrees. So that is the lambda. This is the angle now, lambda, to use the as a basis for solving your R. Your R is actually this is your lambda and this is your R. So we need this angle here, which is already solved. So opposite to that is immediately your R. So we can now solve. This is now ready solving for R. So to solve for R now, based on the figure, so we will try to solve now the R. We have R squared is just equivalent to d sub 2 squared plus 300 squared minus 2d sub 2 times 300 cosine lambda, ending up with your R equivalent now to 337.4337 331. Okay. Now, what's next? Notice that this is exactly the same as the component method. We will try to check later if really by component method this will be the same as this value, magnitude of R. Now, the next is we need to find now theta R. So on the figure given, okay, your theta R is actually this, no? The angle from the x-axis to R. So that shall be your theta R. This one is your theta R. So going nearer to the figure,